Okay, what exactly is our solar system flying through right now? Seriously, it sounds like pure science fiction, but it's an ongoing real-life scientific mystery. Today, we're going to dive into an explainer of a totally fascinating newly published paper titled Local Interstellar Cloud Structure Imprinted in Antarctic Ice by Supernova 60 FE. It was led by Dominic Call and an international team and published through the American Physical Society. And trust me, this is absolutely worth your attention. Because, you might think space is completely empty, right? Just this endless, dark void. But actually, that's a total misconception. We're actually cruising along on a galactic road trip, actively passing through a massive invisible cosmic structure as we orbit the center of the Milky Way. Literally right at this second, our entire solar system is plowing through something called the Local Interstellar Cloud, or the LIC. It's essentially this warm, diffuse galactic fog bank sitting at around 10,000 degrees. And the really wild part, scientists are still trying to figure out exactly where it came from and what the heck it's even made of. Well, that's exactly what this new research is trying to answer. The team basically decided to treat this astrophysical mystery like a giant cosmic crime scene. They wanted to uncover the exact makeup of the interstellar material we're driving through on our daily galactic commute. But to pull that off, they needed a very specific type of evidence. Which brings us to Section 1, the origin mystery. Where did the fog come from? So the absolutely crucial question here was whether this space cloud was born from the violent shockwaves of a supernova explosion. But we can't exactly scoop up interstellar gas with a giant net to check its ingredients, right? Instead, researchers have to hunt for iron-60. This is a super rare radioactive isotope forged in the extreme heat of exploding stars. It acts like a forensic fingerprint for supernovas, and it travels across the galaxy trapped inside microscopic bits of interstellar dust. Basically, if we can find iron-60, we find the ghost of a supernova. Moving to Section 2, the Cosmic Ice Archive, digging for stars on Earth. To catch this microscopic space dust, the researchers did something brilliantly counterintuitive. Rather than building a better telescope and looking up, they looked down, deep down, into the oldest, most isolated ice on Earth. They managed to get their hands on a staggering 295 kilograms of ancient Antarctic ice core from the Dronning Maud Land region. This specific chunk dates back 40,000 to 81,000 years. And they used this prehistoric frozen water to hunt for those rare stellar atoms that fell to Earth millennia ago. This whole process just brilliantly illustrates their mad scientist methodology. I mean, it sounds simple, but it requires extreme precision. First, they carefully melted massive chunks of this ancient ice, making absolutely sure there was zero modern contamination. Then, they used nitric acid to chemically extract the iron. And finally, they put the sample into a giant particle accelerator to literally count the individual iron-60 atoms, one by one. And that takes us to Section 3, the discovery, catching the supernova fingerprint. The sheer improbability of what they found is staggering. They were looking for a literal needle in a continent-sized haystack. Now, to prove this iron actually came from a distant star and not just local space rocks, they measured the ratio of iron-60 against another isotope, manganese-53. And their findings sit solidly above the normal background dust generated by local meteorites. It completely proves they found exactly what they were looking for. The paper notes that the measured ratio is 1.4 sigma above the chondritic ratio. Okay, so what does that mean in plain English? Well, even though they only counted a literal handful of atoms, just 7 detector events to be exact, that tiny trace is statistically significant enough to definitively prove this ancient ice is holding genuine interstellar supernova debris. Plus, the background measurements showed absolutely 0 events, which gives us incredibly high confidence in this result. But here's where the plot thickens, and it really builds our cosmic timeline. When we compare the iron found in this 40 to 80,000-year-old ice to the iron found in recent Antarctic surface snow, a shocking discrepancy emerges. The old ice has a much, much lower influx of interstellar iron compared to the snow falling today. When you compile all this deposition data over time, it totally connects the dots of our galactic journey. It reveals that the supernova iron falling on Earth 40 to 80,000 years ago was significantly lower than the amount showering down on us right now. The influx has changed drastically over that time period. So what are the practical implications of all this? It actually leaves us with a couple of wild realities about our cosmic road trip. Either we just recently drove into the thickest part of this interstellar fog bank, or the cloud itself is incredibly clumpy and we're just now hitting dense patches of supernova dust. Either way, it completely proves the local interstellar cloud is acting as this massive cosmic archive, holding on to ancient supernova debris. Which brings us to Section 4, plotting our galactic journey. What the ice tells us about space. By mapping out these microscopic radioactive traces buried in the Antarctic ice, we aren't just looking at Earth's history. We're quite literally drawing a map of the interstellar space our solar system has been traveling through for millennia. It leaves us with this thrilling realization. Earth isn't just a rock floating in space. It is an active cosmic voyage recorder. Which really makes you wonder, if ancient ice can perfectly map our path through the galaxy, what other cosmic secrets are buried right beneath our feet, just waiting to be discovered?